Welcome to a new episode of Science in Context. I'm Ryan, and this week I'm joined by Professor Steven Riley to speak about influenza and how traces of past infections in our blood could ultimately help to design better vaccine programs. Steven, what is infection history and how does it relate to flu?
Thanks, Ryan. Yeah, so some infections that we get, we're likely only to get them once. So, looking back in time when lots of people did get measles in the UK, but expect to only have it once and then they get lifelong immunity. Other pathogens aren't quite the same. So influenza is an example of something that infects people repeated times throughout the course of their life. And every time you do get infected by influenza or you have a vaccine, it leaves a mark on your immune system. So some of the work that we do is getting blood samples from people and then analysing what exactly they've been exposed to across the whole course of their life.
And how do computer models help us to understand the sort of wider immune landscape?
As you can imagine, everyone gets infected at slightly different times during their life and with different strains. There are multiple strains of influenza that circulate. So it's very difficult to look at the data for any one person and understand exactly what's happened. So what we do is we use mathematical models and computers to search through all the kind of space of models, all the different explanations for how people have been infected, and come up with the most likely infection history for each of the people in our study. And it kind of reveals lots of interesting patterns, with space and with age and with time.
And how could this kind of information be used in practice?
As we move forward, vaccines are getting more sophisticated. So for both COVID and influenza, we're basing the vaccines on lots of different strains so that they're able to respond across a broader spectrum of your immune response. And they're looking at what's called highly valent vaccines, where they're designed to respond against many, many strains. When we get into that kind of intervention, then having a really detailed understanding of the population immune landscape is going to make it far easier for us to try and optimize those highly valent vaccines for both flu and for COVID going forwards.